Ladies and gentlemen, welcome back to another live stream. So this is the third part of this series where I'm trying to distill my 8 years of experience in programming in general by trying to teach you guys some C programming. Alright, so let's get going. Let me share the stream real quick. There we go. Copy video URL. Please join my Discord server. You can find the link down in the description below. Everyone live. There we go. So if you haven't watched my second and first stream, like the first and second part, please go ahead and watch it first. So the first part I basically covered some essentials, and for the second I covered how to install libraries and also how to make a painting program as an example of using Raylib. Right, so this is what we have made. Well, there is some new things that I'm gonna cover in this stream, and I'm probably in this stream gonna basically go ahead and improve the application that we have made before, basically the painting program. So yeah, that's basically what we're gonna work on this stream, hopefully. So yeah, let me grab the chat here, pop out the chat. Alrighty. There we go. Alright, let's go ahead to Visual Studio and let's see what we got. Alright, so this is the program that we had last stream. Basically, we just had this, and basically I could use my mouse wheel to change the width of this thing, right? And this is what I had, what we have implemented in the previous stream. Well, hold on, what the, okay, there you go. That's pretty cool. Now we're gonna improve this, of course. So the first thing first is here I've shown you a bit of mathematics on how to do linear interpolation yourself, and then I've shown you how to do quadratic interpolation by giving it basically A, B, and C, and it basically would give you, calculate the interpolation from A to C, where B is like a control point for the interpolation, and T is like the kind of the percentage from A to B, right? So like T, if it's 0, then you're gonna be at the start in A. And if it's 1, you're gonna be in B. And in between, it's gonna be interpolated basically. So you had basically a smooth curve essentially. Now, what we're gonna do today is we don't really actually need to do these calculations ourselves, because apparently Raylib already have a function for that called draw Bezier, I think. So let's go to Raylib cheat sheet real quick. Cheat sheet, I think, yeah, there you go. So I already have some Bezier functions, though I don't want Bezier exactly, I want Catmull-Rom. So splines. Why I want Catmull-Rom? Because, well, Bezier, I think a lot of people already know Bezier. Like, you have some points, and some control points. But the problem with Bezier is that the curve wouldn't necessarily go through the control points, right? It's just influenced by the control points, but not necessarily go through it, right? But in the case of Catmull-Rom, it actually have to go through all the points. But of course, both of them actually create a smooth curve. That's exactly why I'm using splines here. So the painting would be very smooth. And now here I'm gonna actually make it smoother, first of all, and second of all, it's gonna be more correct. Because like the curve that would be produced would go over all the points. and it would still be smooth, right? And also better performance, because I'm not gonna be doing this kind of loop right here where I'm calculating like a lot of points every time and drawing a new circle every time. I'm gonna just draw one whole spline basically. Okay, let's see how we can do this. First of all, we don't need these anymore, these calculations anymore. We're not gonna do them like manually anymore, so we're gonna also remove this stuff. And for now, I guess let's just, you know, do this. Basically, I'm gonna comment it out. I'm gonna actually use here, I mean, I can try to explain a bit about splines, honestly. Yeah, I may be able to. Let me see, where is it called? What that thing is called? Oh my god. Whiteboard, I think. Yeah, there we go. Microsoft Whiteboard. Let me see. Let me try to explain this a bit. All right, you start with a blank canvas. All right, let's see. So we have a point A, okay? And we have a point B, right? So linear interpolation is basically would give you like a line that goes from A up to B, a very linear straight line, nothing fancy. Like here it would be t is equal to 0.5, right? Here t would be equal to 0 in A, and at the end point it would be equal to 1. So basically 1%, here 0%, and here 50%. And let's say, for example, here it would be 0.75%, and so on and so on. So here, what I have there in that loop, here in this loop, I'm basically going through and making, you know, I'm going through all those t's one by one and putting a circle there so I could like draw the whole line, basically. That's what I'm doing there. And then afterwards, I use the quad instead of a lerp or linear interpolation. I use quadratic interpolation. Now, quadratic interpolation, you still, of course, have A and B, right? But now you're going to have another point C, which is going to be your control point, right? Now, basically, what's going to happen here is that, well, I actually removed that code. Let me grab it back, actually. Hold on. Let me grab back the code. Okay, so notice that I have D1 and D2 here. So, of course, A, B, and C, where B is the control point, C is the endpoint, and A is the endpoint, and, of course, T is a value from 0 to 1. Now, I could rename this to something more meaningful, like, how do you refactor this? Let me see. Refactor, rename. So let's call this line 1, and let's call this line 2. How do you refactor this again? There we go. Line 2. All right, so basically we use lerp here. We use this linear interpolation that I've talked about here, right? Just a simple linear interpolation. So here we're using it. We're using it from A to B, right? So we're basically doing linear interpolation from A to B. So, well, actually not from A to B, but basically here the C is the control point. So from A to C, right? So we're doing a linear interpolation here, just like I've shown you before, right? Just like that. And I'm also doing from C to B, linear interpolation, right? And so on. Afterwards, what I do, the actual curve would be, so like, as you can see here, the actual return value is the lerp again. So we lerp the line 1 with the line 2, right? So, how would I even explain this? So for example, if you take, let's say t is equal to 0.5, what's going to happen with this quadratic thing is that you would have, like, let's say this is 0.5 and this is 0.5, right? In this line 1, and line 2 0.5 here. What you're gonna do is we're gonna like make a new line because we linear interpolate it again, right? And so t 0.5, we're gonna put a point here. And like if you do this for all the t's, you're gonna have a curve, right? kind of something like this, where it goes from A to B, and then this C controls it, right? Influences its curve, right? So you get basically a smooth curve, essentially. Well, actually, it would be something more like, I guess, like this maybe, or something like that. But yeah, the more this is like, if it's here in the line, it would be just a straight line, just like a normal lerp. But the more you like the C is outside of the line, it would curve even more. But yeah, hopefully that just makes it clear a bit. But yeah, Catmull-Rom though is a bit different. It also makes a spline, but anyways, let's go back to the actual implementation here right now. So as I said, we're not gonna need these stuff anymore. We're not gonna do them manually. We're gonna use raylib because we already have a function for that. But if the raylib didn't have this function, then we had to do it this way. But anyways, so I'm just gonna comment this out, and then we're gonna say draw Catmull-Rom, spline Catmull-Rom. There we go. Oops. Catmull, well, the heck. There we go. All right. So here we got vector 2 points, and as you can see, it's a pointer. So, and then afterwards you get an integer point count, right? Because the thing is, arrays in C, we don't have real arrays in some sense, especially when you pass them through a function argument. That array basically decays into a pointer, so it loses its size, right? So like you cannot deduce the size of the array from a pointer, essentially. A pointer is basically just an address. It just points to something. Just like in strings, like it actually just points to the first character in the string, but like to actually find out to find out the length of the string, what we have is like a null, what is it called? This thing right here. Null character, I think. I don't remember what it's called exactly, but yeah, the moment you find this, it means that the string have ended, you know. So the functions that uses that just ends there. It knows that the length of the string is done. But yeah, so here what we have here is that I need to give it the like a pointer to the array, to the start of the array, and then tell it how much like how big is the array, how much elements there is. So that's exactly what I'm gonna do here. So we don't have an array, we have 3 variables here. For our points, we have a second order mouse position, an old mouse position, and a mouse position. So how we could do that? Well, I could go ahead and create an array here. So vector 2 points is equal to, well, let me just remove AI, by the way. Hold on a second. All right, so yeah, let's go. What the heck? I'm pretty much, I removed it. What the hell? I did. I don't know what the heck is going on here. That's very strange. Anyways, let's see what we got here. So the first point would be G second order mouse position, and then the, oh crap, points should be like this. It should be an array of vector 2s, right? And G old mouse position, and then G mouse position. There we go. Now here what we're gonna do is we're gonna pass in the points. We're gonna pass in the point count, so how much points there is. And we can get that by saying count of points, right? And then float thickness. So float thickness, it would be G brush color, brush size. And then the color would be G brush color. Okay, perfect. Let's see what we got now. I think that's basically it, yeah. Let me try this out. Find out if it works. Huh. I mean, it doesn't really seem like it. Interesting. Why that's the case. G signal or mouse position, all mouse position, then draw spline Catmull-Rom, count of points. Yeah, that should work. Why not? It doesn't. That's weird. So here's the points here. I mean, that looks correct to me. What in the world? Probably missing something here. Hold on a second. I already tried this and it worked, and for some reason right now it doesn't work. Here's the code that I've done out of the stream. But it was like using a mouse. Oh, my bad. I see now why. I just remembered. Okay, so the thing is about the Catmull-Rom thing is that it takes 4 points, right? Like, let me see if I can find, or I could just basically show it to you here. Okay. So let me try to explain it here. So Catmull-Rom is a bit different. It takes at least 4 points. So like, let's say these points right here, these points. And what it does is that it doesn't actually draw a line between, oops, what the heck is happening here? What? That's very strange, hold on. Okay, so it doesn't draw a line between the first point and the second. It just uses it to actually curve this thing. Just uses it to influence the curve, basically. Just like that, kind of. So the first and the last one, they're just used to influence the curve direction, right? And then the ones in the middle are actually used to draw the line. So yeah, let's say if we have maybe, I don't know, 1, 2, 3, 4, 5. So like 4 points. Is the stream fine, by the way? Let me see. Yeah, seems good to me. Perfect. Anyways, so it would basically be something like this, but then you would have a line like this which passes through all the points, and it's going to be smooth, basically. And that's basically how it works. Now this didn't work here for me because I forgot about that fact for a moment, and I only passed 3 points. That's why it didn't work. So to actually fix that, what I could do for now is to add another point. And there's 2 ways I could do this. I could either just duplicate this mouse position, right, and add it here, or I could duplicate this second older mouse position and add it here in the beginning. I think I would go with the latter for now, but we're actually gonna have more. We're gonna generate more points in a second, but this should work for now. Okay, let's see now, and this is too big, I think. Hold on, that's kind of huge. Let's set it to 8, honestly. And yeah, and also one thing is that the brush size, when it comes to the circle, this doesn't take the actual, like, it only takes the radius, so we have to halve this by 2. And yeah, let's go. So as you can see right now, it actually works with the curve. And even better, no matter what the FPS is, it still looks very, very good. Let me show you. And we're no longer like drawing, you know, hundreds of circles in every frame. We're just drawing one curve, one single curve here, which is amazing. So let me see, if I set the FPS here to 10, and let me see here. So right now FPS is 10, but it's still quite smooth. I mean, it's not very, very smooth, but yeah. That's the only thing you can get. Though we can actually make it even smoother by actually having a fourth point at least, or more. Now the thing is, hello Loop Luminary, welcome to the live stream. How's it going, man? So what we gonna do? Let's see. And by the way, let's call this something else. Let's call this Codotaku painting program, I guess. And let's see. So what I'm gonna do, instead of having all these messy variables like this, where I'm gonna have a mouse position, then an old mouse position, then a second older mouse position, and so on, this sucks. It's not extendable and it sucks. I have to always come up with a name and so on, and just overall messy. So what we're gonna actually do instead is to have a mouse position buffer, right? Where we're gonna buffer the mouse position on like previous n frames, right? It could also be called a ring buffer though, but whatever. So mouse position buffer, and let's say 4 for now, because that's the minimum points that we need. So we're gonna basically buffer the mouse position over 4 frames, over the previous 4 frames. And we're gonna use that to smooth out the curve essentially. So yeah. All right, let's see how we're gonna do this. We don't need this stuff anymore, honestly. And for points, we're not gonna need that anymore either. So right now, points, we're gonna do it directly. Like we're just gonna say mouse position buffer. So G mouse position buffer, and here we're gonna say count of G mouse position buffer. And for the mouse position, I'm gonna create like here a vector 2 mouse position is equal to G mouse position buffer. I'm gonna, the actual mouse position of this frame would be the last position in the buffer. So it would basically be count of what? Yeah, G mouse position, right? Buffer -1 to get the last element, because the index of the last element is the count of the array -1, basically. So yeah, for example, like if you have an array of 1 element, then the last element is also the first, which is the index 0. But anyway, right now I could actually pass in this mouse position variable to all of them. Though honestly, it's just a constant, so let's make it that. And the same thing here. Now here, we don't have these individual, variables anymore. We actually have an array, so how are we gonna do this? Well, honestly, we don't need this anymore. We're gonna do it here instead in another way. So, and we're gonna remove this one too, I think. Well, at least for now. So here's the deal. What I'm gonna do is I'm gonna shift all the elements in the mouse position buffer. I need to shift them left by 1, okay? So how I'm gonna do that? Well, that's gonna be interesting, I guess. So for integer I is equal to 0, I is less than count of G mouse position buffer, I++, and what we're gonna do, I is less than int inside, well, this should be size t. All right, perfect. So how are we gonna do this? What I basically want to do is, let's say we have an array here, right, of elements. Like, let's say, oops, we have 3 elements, or let's say 4, because that's exactly what we have here. And let's say it contains 4 elements, 1, 2, 3, and 4. Now, if we want to basically shift this, all these elements down, we basically want to shift all of these, right, left by 1, and so this we're not going to need it anymore, basically. And here we're going to put the new mouse position at the end, basically. So what we basically want here to happen is that we're going to have a new array. Whoops, oh my god. So we're going to have like 2, 3, 4. And then here we're going to have the 5th element, which is the new mouse position, essentially. So the problem right now is how we can do this shifting operation using a for loop. Well, let me first of all implement it. So we're going to do it using g mouse position buffer I is equal to what? It's equal to, so for example, you know, here this is the index 1, right? Which index it became here? It became index 0, right? So -1. Or hold on, no. Here we're actually setting the new index. So the new index is here, 0. Right? And then it became 1, I think. So basically g mouse position buffer I plus 1. Right, in fact probably the opposite. Hold on, I'm kind of trying to think here. Let me open up the window. I needed oxygen to process. Let's see. Alrighty. Okay, hold on. I mean, you know what? Let's just try this stuff and see what's gonna happen, honestly. Mouse position buffer I equal to G mouse position I plus 1. Yeah, and here we're gonna probably want -1. And we're gonna see, I guess we're gonna find out what's gonna happen here exactly. Yep, pretty much. And then finally, at the end of the day, what we want is g mouse position buffer count of, again, well, honestly, instead of having to do count of multiple times, you could just make a variable here. So like const size t, I don't know, mouse position count, I guess, is equal to this, essentially. And so mouse position count -1 is equal to a new mouse position. And yeah. But let's just initialize that array with some values so we could see if the shifting actually works as I expect or not. So we could say mouse position buffer is equal to vector 2, right? Well, vector 2, well, hold on. Actually, I could probably just do this. One, 2, 2. I thought this only works in C++, but apparently it seems to work here too, I guess. Or maybe I'm wrong. What's happening? Oh, comma. Alright, let's see what's gonna happen here. So I'm gonna put a breakpoint and then I'm gonna debug this and see if this works as I expect or not. If the computer is doing what I want or not. Alright, let's see. So where's my mouse position buffer? Here we go. And this is I+1 and this is I essentially. So that's pretty sick. Alright, so 1, 2, 3, and 4. Perfect. Let's see what's gonna happen. So the first one, what happened? Well, let's just go through it all honestly and then see what is the result first of all. Okay, let's see. So 0 is 2, 2, 3, 3, 4. So 2, 3, 4. And then here. I don't think that's what we want, or is it? Actually, it is, yeah. So it was 1, 2, 3, 4. Now just 2, 3, 4. And then we're gonna set that mouse position buffer last element to mouse position. Yeah, I think that's probably exactly right, yeah. So let's go with that. And of course here I'm saying -1 because I don't want to include the last element, right? Because I+1, otherwise it would go outside of the buffer basically. So I gotta be careful about that one there. So yeah. Alrighty, so what I'm gonna do now. Yeah, I think we could use this right now. Let's actually see. And there we go. So right now it is actually working. But the problem is here I don't really see it working until I paint stuff. Now instead of having a boring circle here, what I'm gonna do, I'm kind of gonna like preview the Catmull-Rom spline that the user would actually be able to create if he draws. So instead of draw a circle V, I'm gonna do the exact same thing here in the actual window. So if you remember here, we're actually drawing into the canvas because of this begin texture emoji canvas. And here we're ending it. So after that, we're just drawing into the window, which of course doesn't persist. It just gets cleared in the next frame. So let's actually do this right now and see. And there you go, look at that. Walaikum salam, Robert, welcome to the stream. And there we go, as you can see, we're actually seeing right now the curve, which is pretty sick. Now the real magic here is, and by the way, I don't need this anymore. That was just for me to debug that thing, really. So now the real magic here that I could do is I could actually make this into any number I want. Of course, as long as it doesn't blow off the stack, but let's not talk about that now. So let's say, for example, 10. Sorry, not the colors. I'm not talking about the talking about the mouse position buffer. All right. So instead of like buffering, or should I say accumulating the mouse positions of the previous 4 frames, we could even, let's say, 10 frames, right? And that would actually, right now, instead of 4, it would be 10 frames. So as you can see, I'm accumulating all the mouse positions from 10 frames. Look at that. That's pretty sick. That's pretty cool, man. Love that. I could even go crazier. Now this is like I have VSync on and my monitor is 75 Hz, which means that this is probably running at 75 FPS. So if I want, you know, to buffer the mouse position over 1 second, then I could say 75 here, right? And there we go. Now this would buffer up like for a whole second. And it would use that to actually draw smooth stuff, smoother curves from the older mouse positions in the frame. So yeah, but 4 I think is probably way more than enough. And in fact, it's the minimum there. So yeah, that's basically it for that part. All right, now the real question is what I want to do next. By the way, we could just omit these things here. We don't need them. What else? Let's omit these just to make this a little bit cleaner. cool. Anything else? This one too. Alright, so I think what I'm gonna try to probably do next is to actually be able to change where I draw this texture, like where I draw my canvas, because right now my canvas is taking my whole window, right? But that's not exactly how like applications like Photoshop works. They actually have the canvas only take a part of the actual window, and the other parts are, let's say, for tools like here the colors and so on, because right now I can't really actually draw over this without triggering the buttons and so on, as you can see here. Look at that. You see what I mean there? Which is very interesting. So how can I do that? Well, there's gonna be a problem that would pop up, but let's just see. Let me show you what's gonna be the problem by actually doing it. So here we're using draw texture rect, which only gives us a source rect, but that's not the only thing that we need here. We also need a destination rect right now, I think. So for that, we're gonna need to use this version of the function, which is the professional version. We're professionals right now. So here we got the source rectangle, and we also have the destination rectangle, and then we also have a vector to origin and we also have a float rotation and color tint. So the new attributes from this version of the function is the destination, first of all, the origin, and the rotation. All of these would be available for us to use, basically. So let's actually try to use that. So let's comment this out. And in fact, AI could probably help us here. If I don't have... Let me see if we can actually figure it out. Like, I'll just say draw texture pro. Let's see if it's gonna figure it out or not. It should be able to. It's not a very hard thing. Let me see. So source 0, 0, and of course the AI is actually relying on the comment that I've done here too. So it knows exactly that I'm trying to replace this kind of code basically with this new code, but I want to use the pro version. So here it replaced the source correctly. Oh, interesting. The AI actually showed me something. See, it's how programming is meant to be done. Yeah. So I actually noticed something from the AI here is that I don't really need to grab the width and the height of the window. I could just grab it from the canvas itself, the texture. Interesting. All right, so we don't need that apparently. Oh, well, we actually do need it right now for the calculations of the destination. Yeah, I see. All right, that's interesting. Cool. All right, so this would basically mean it would take the whole canvas as a source rectangle. We don't want to draw only like a part of the canvas. We want to draw the whole canvas. Now for a destination is like, where in the window do we want to draw the canvas? That's what the destination is here. Currently here it's just the width and the height of the actual window, which means the whole window. But what happens if we actually make it, let's say, so our buttons, how big they are? They're as big as like 32 pixels, right? And we have like a margin of 8, which means 40. So let's say 50, okay? Let's say we want to offset the canvas by 50 pixels, okay? And let's see what's gonna happen. You're gonna find some problem here when we offset this. I mean, it's gonna work. Yeah, we're gonna have an offset canvas. There you go. And also one other thing that you can notice here is that we have this weird crap because we weren't really clearing the window, and we still aren't. That's why we have this weird artifacts here. So, and I wasn't like clearing the window because like the canvas was actually overriding the whole window, but right now it's not doing that anymore. So I have to make sure to actually, you know, clear the window properly. So how can I do that? Well, Well, clear background here, or actually clear maybe? I forgot which function, oh my god. Yeah, pretty much clear background. What the heck is going on? Alright, let's go and let's see. Alright, right now that's no longer a problem. But anyways, so you're gonna notice here that, look at that. So it's actually offset. My drawing doesn't match my canvas because my canvas right now is offset, but my mouse position calculations isn't really taking into account that transformation, right? And that sucks, of course. So how we could fix that? Well. Let's see. Alrighty, draw text, text format, draw spline, Catmull-Rom. So we basically have to transform, I think, either the mouse positions or the canvas drawings itself, or let's just, I guess, maybe go with the mouse positions instead, maybe. So here, when we say get mouse position, we have to make sure to transform the mouse position into the canvas coordinate system. So like from the window coordinate system to the canvas coordinate system, because basically the problem that we have here is that before we didn't have this problem because like the window coordinate system and the canvas coordinate system was the same. Why? Because, well, they had the same width, the same height, and the same offset, like the same position. Right now they no longer do, so we have to have like some sort of function, right, that basically gives us a vector 2 and takes a vector 2, and it would basically transform like screen coordinates to window coordinates to canvas coordinates, or to rect coords, to be very generic there. Let's see if the AI could actually figure it out without having, let's see. And let's see if that's correct. So it said that we're getting the window chords and then the rectangle. Cool, lovely. So that's basically the canvas rectangle, or rect anyways. Now here we're turning a new vector 2, which is window chords.x minus rect.x and window chords.y minus rect.y. Yeah, that actually does solve one part of the problem, but not the whole. But for now, since we're only offsetting stuff, this should work. So what I'm gonna do right now is to simply, and also let's just call this window to rect chords, I think. We could also call this window to rect chords like that, or, but yeah, whatever, anyways. So here, instead of get mouse position, we're gonna transform that mouse position first of all. And well, we need to store that thing. Alrighty, so how are we gonna do that? Well, we're gonna come here and we're gonna say rect canvas. Rect, right? Canvas. Why the heck? Rectangle, okay. Canvas rect. Canvas rect. Alrighty. So what we're gonna do next now? We gotta actually initialize it, I think. Canvas rect. rectangle, and yeah, the AI already figured out that I wanted to do the same thing that I've done there, which is 50 pixels down, right? So yeah, now I could actually come back here, and instead of doing this, I'm just gonna say G canvas rect, right? And now let's go down here to where we were. Window to rect chords, and here I'm gonna give it the get mouse position please and the G canvas rect. Perfecto. All right, let's go, and this should probably work, I think. Let's see, and yeah, look at that, it does actually work. But now we have a problem with the actual other thing for some reason, which is interesting. Why? So here we got G. Oh yeah, I see. I see. Well, that's interesting. Interesting. So now I could either transform. Yeah, honestly, I'm not gonna do it here. Alright, I'm gonna keep the raw get mouse position for this one. But then I'm gonna create a new array that is transformed for the canvas drawings. So for the canvas drawings here, where is it? And I actually don't need this anymore. Yeah. And now the problem here is basically here, right? So how we can do this? I'm not sure honestly, but right now I guess let's just add another variable, maybe here, ODS. I mean, it's not really needed actually. Yeah, it's not really needed, I think. So basically I need to copy the mouse position buffer to a new buffer so I could transform it, right? So yeah, let's do it just here, honestly. So we're gonna say canvas mouse position buffer. Let's see if the AI actually figures it out. I mean, it can't really do much right now. I'll just say for, and it should have a for loop where basically it transforms. Yeah, exactly, perfect. The AI figured it out already. That's cool. Window to. Why the heck that function doesn't exist? What? That's very strange, really. What's wrong with you? Oh, I just remembered that I'm in C programming language, so stuff only shows up when like basically functions that are defined later on you can't use them, but like in Rust for example you can actually do that. So there's two solutions here. We can either basically take this function and declare it and implement it before this draw function. Otherwise, we can actually forward declare it by doing kind of like a header. So we just forward declare it like this. And it doesn't matter, like the implementation could come afterwards, but the declaration should always come beforehand. Right, so this would work. Otherwise, honestly, in this case, we could just like really take the whole function, honestly. Kind of hate declaration, like forward decline functions. Unless if it's a library, so yeah, because like you have multiple lines of code to keep track of, like when you change the forward declaration you have to change the other one, but yeah, whatever. Anyways, so this should work now. Yeah, so basically I'm going through all the mouse position buffer elements and then I'm transforming them using this window to rect chords function. And yeah, that's essentially it. So of course I'm making a new array every frame, though it doesn't really matter. This is just the stack. I'm not really allocating memory. So that's basically it. yeah. So now instead of using the mouse position buffer here, I'm gonna use the canvas position buffer. But how the heck, hold on. There we go. Now let's actually run this and see. This should work now. So right now we should have both. Yeah, there we go. So both are working correctly right now. And that's pretty sick. And I'm not sure why I can't really click these buttons using my pen. But yeah, whichever. So right now, as you can see, it actually works, which is perfect. All right, cool, lovely. Lovely, lovely. So what I'm gonna do next now. Yeah, so right now we have done the offsetting, but what if we want to actually change the size of the actual canvas? Now this is where the second part comes in, where this function that the AI generated won't be enough. So as you can see, AI could really help you, like, because basically here you're not really wanting to like learn how to code. Here we're learning how to program, right? So the code could be basically done by the AI if it's something very simple, right? But of course you have to know exactly what you're doing. For example, here when the window to rect chords, oh my god, I hate this. When the window to rect chords got generated, right? By the AI, it actually only accounted for the position, but it didn't account if the rectangle is not matching the window chord's rectangle size. But let me show you first of all what is the problem here, and then we can see how we can solve that. So okay, let's go back down to canvas rect. Let's say instead of screen width divide by 2, okay? And screen height divide by 2. So basically the canvas, instead of being like as big as the window, it should be half of the window, let's say. And you're gonna find out hopefully what's the problem here. And look at that. So it doesn't match once again. I mean, look at that. In the top left corner it actually matches, but the more you go, like you go outside, like basically far away from the origin point, you actually, it doesn't match up anymore. It goes further, because basically the scale is skewed, right? So the scale of the canvas is smaller by 2 times than the scale of the actual window. So the coordinates should also be scaled down. So how we can do this? Well, let's see if the AI could actually generate a more complete solution right now if I actually just remove what it did before. And let's see. Nah, it didn't, apparently. So let's figure it out ourselves then. Alrighty. Now the problem is we don't actually have the window coordinates, first of all. And honestly, this doesn't really have to be the window coordinates. It could be any rect to rect, really. Yeah, actually that is true. So like, I could say this should be called transform rect chords, let's say, right? Now let me actually make another more generic function here. So you're gonna have like a chords vector 2 points, yeah, exactly. Then you're gonna have like a rectangle source, and then a rectangle this. Oh yeah, there we go. Right now the AI actually understood the assignment. Okay, so here we got like a point coordinates, then we got a source rectangle and a destination rectangle. So this is not tied anymore to the actual window. This should be generic on any rectangle, and we could use it anywhere where we have this operation of transforming from one rectangle coordinate system to another. Right, and as you can see, the AI already understood what the heck we want to do here. So of course we have the stuff that it done before, the half of the solution where like the destination and the source size actually matches, but the offset doesn't, or the position doesn't. And here is the other part where we actually scale down or up the actual coordinates by source.width times destination.width plus destination.x and so on. So let's see if this actually works. So here what we're gonna do is, let's see the AI what it can do here, if you can figure it out. Rectangle, so the source, and notice here when we actually use the AI, it's not like the AI would do everything. You still have to review the code and make sure it is correct and complete. All right, so that's one con of using AI, is that you have to make sure it's generating proper code, right? So like instead of becoming the coder, you actually become the reviewer, right? So you review the AI code. But anyways, so here what's up. So the source rectangle should be basically the rectangle of the window, and get current screen width. So I don't think there's a function in Rail to just get the rectangle of the window. You have to use this get screen width and so on. Now this gives us an integer, but rectangle of course has like half floats, right? Yep, floats, of course, that makes sense. So here we're casting it to float, x and y of course 0, 0. Like the window would always be in the, you know, origin. And get screen height here for the height. Okay, cool. And the destination of course is the canvas rectangle, which is correct. Pretty sick. Or we could just say that this is like, we could put it in a variable, call it window rect, and basically say, oh yeah, there we go. Perfect. And now let's actually see if this works by any chance. And actually it doesn't apparently. Huh. It doesn't. So the AI is probably wrong, I would guess. I mean, honestly, the scale is, I guess, maybe kind of correct. I don't know. Let's see what we have here. So let's go back to our first kind of solution. And let's go step by step then. Alrighty, let's see. So point.x minus source.x and point.y. So right now the actual, oh, actually that's not correct. Huh. What the heck? Very confused right now. What we had before even. No, it should be destination, my bad. Destination here. So maybe that was actually the problem there. I don't know. Let's see. And yeah, right now the actual offset is correct. Now we just gotta figure out the scale. Now for the scale, let me try to think of a solution. I think I'm just gonna like, so basically here, let's see. What happens if I do times 2 just real quick? Because I know that that's the scale that we need here. Oh, I can't actually do that. Not in C++. We don't have operator overload in here. So we have to use vector 2 scale basically. Actually, what? No. No. Okay. I see. Alright, never mind. My bad. Okay, cool. So let's actually try this out and see. I think it's maybe the actual opposite, like divide by 2, but let's see. No, yeah, it's Perfect, yeah, there we go. That's pretty sick. Lovely. So as you can see, it actually works. Now let me actually make this, like right now I'm just hard coding it because I already know the scale. Let's actually calculate the scale, how we can do that. So essentially it would be, is there like a function to get the rectangle size? Let me see what's the rectangle stuff there is. I mean, I could just calculate it myself, but let's see if there's already some helper functions, because if there is, why bother? Right, so rectangle. I mean, I don't really see any, honestly. Yeah, I don't really see any, so I guess we're just gonna have to do it ourselves then. Fine. So here times, instead of 2, we're gonna say destination. Oh, we already have the width and the height, yeah. So that makes sense, right? So here the x, so we're gonna use the width, divided by src.width. It may be the opposite though, but we'll see. Destination.height divided by destination dot, src.height. Let's see if this works. So as you've seen, the AI actually gives us wrong solutions there, and then we have to just figure it out ourselves. And apparently that's not the right order. It should be src divided by destination. Otherwise it should do a divide here, but yeah. So we'll just say src destination. And there we go. And yeah, right now it actually works properly. One thing though here is that I'm not accounting for the destination x, I think, or source x, or yeah, the source x and y. For that, honestly, I'm not sure. Probably plus src.x, I would guess, plus src.y. I'm not sure though. I need somehow to like test that. But here my window is actually 0, 0, so I can't really test that for now. But anyway, if we ever need it for that later on, where the source doesn't have a 0, 0 in the source x and y, then we can test that and fix it. Anyways, now here, instead of doing it this way manually, I think we could probably use vectors instead. So like a point is already, let's see. So here we got like point minus destination position. So how I could do that? Hold on, I'm gonna get back real quick. Okay, I'm back. Alright, let's see how we could actually do this. Let's see. So vector2 subtract point from destination dot position, but unfortunately we don't have a position, so we just have to create a new vector2 where we have the destination.x and destination.y here. That's the first thing. The second thing is that we do times source.width divided by destination.width. So here we're scaling, right? Yeah, we're scaling by a scalar, not a vector. Yep, so let's go ahead and do that too. So we gotta say vector2 scale. Now in C++, we actually, at least in the new version of Raylib, there is actually operator overloading, so you could just use the same operators with the vectors, but not in C. In C we don't have operator overloading, so you just have to use actual functions like this. So alrighty, let's see what we got. So vector2 subtract, comma source.width divide by destination. Actually, no. We need vector2 multiplying because they're different. well, vector 2 multiply. Here we're gonna need a vector 2, right? So there we go, perfect. And yeah, there we go. That's basically how you do it using vectors instead of just scalars one by one. So that's pretty sick. Let's actually try this just to make sure that everything's still working properly, and no, it's not for some reason. We're probably missing something here, I guess. So vector 2 multiply. So here we got that. Okay, where's the missing thing here? Syntax error. What? Let's see. I don't know, let's destructure this because this is kind of hard to track down. Let's see. So vector 2a, let's say, is equal to this part of the equation. Well, not the equation, the calculation, right? So a, and here we got so this is kind of like actually the offsetted point, right? But anyway, that's not the thing right now. Let's try to run this now. Still sucks, I guess. Yeah, I guess then maybe we actually have to say vector 2 for some reason here, like this. Is that the case? What in the world? Yeah, probably here too. That's weird. I mean, it worked before. Why not now? Yeah, apparently I had to. I'm not sure why, but anyways, right now as you can see, it actually works. Perfect. So now I could change my canvas position and scale to anywhere in the screen, which is cool. Perfecto. All right. Now the other thing that I need here is to actually be able to like have a bigger canvas. Yeah, to have a bigger or smaller, well, bigger canvas than the window. Well, and we probably also need zooming though, which is very interesting. But by the way, we don't need actually like a variable there. And so yeah, that's basically it. Alright, so what's next? Let's see what we got here. The window rect, the canvas rect is the destination. Source in the window rect. So how much time has passed by right now? So I'm just gonna take a little bit of a break, around 5 minutes, and then we're gonna come back. Okay, I'm back. Okay, Robert, I just see so many words on the screen. Yeah, especially that, like, the thing is I'm still like trying to get through this, so I didn't even try to like split this up into functions and so on, so it's kind of spaghetti right now. But at least it's actually just C code, so nothing fancy, you know. Nothing crazy going on. So at the end of the day, it's just function calls, no crazy operator overload and whatever, you know, RAI and stuff like that. But anyways, so right now, I guess to the next feature that I want to implement here. Did I actually get the mic on, by the way? Yes, I did. Cool. Alright, so here's the features that I'd like to maybe implement. So first of all, a better GUI, better UI, which is like the graphical interface. The other thing is maybe networking at some point, like being able to draw, like multiple people can draw through the network, right? The other thing that I'd like to add is smooth brush, like feathering the brush dynamically, smooth brush using shaders. And what else? Let's see. So GUI networking, smooth brush, also zooming into the canvas. Right, so these are the things that I'd like to do. And for GUI, there is like, yeah, we could indeed just go on and implement the GUI ourselves, but as you can see, it's very primitive this way. But luckily there is a better way, which is called Ray GUI. So it's still Raylib. It's just that instead of just using rectangles and so on, we actually use a dedicated thing in Raylib called Ray GUI here. It's an immediate mode GUI library, immediate mode. So there is retained mode GUI libraries and there is immediate mode. Immediate mode, it actually renders the whole or draws the whole GUI every frame. Just like we have here, we're actually drawing the whole GUI, like all the buttons every frame. On retained mode though, that's not the case. Well, I mean, we're still drawing, yeah, we're still drawing the whole GUI every frame. But like you're not updating the whole GUI every frame, so you're not creating the whole GUI every frame, the whole GUI state, right? So immediate mode GUIs are much easier to use. Retained mode GUIs are more efficient, especially like, let's say, battery, like conserving the battery and so on, and performance. But yeah, most of the time immediate mode should be fine. But anyways, was designed as an auxiliary module for Raylib to create simple GUI interface using Raylib graphic style, simple colors, plain rectangular shape, white borders. Okay, perfect. So so I include RayGUI.h. I'm not sure if that Nugget package actually have that. Let me see. Hopefully it does, because otherwise we... Actually, it's just a header only library, I think, so I could easily add it myself, but that kind of sucks. Yeah, it doesn't seem to exist there. Is there like a Nugget package for that too, maybe? By any chance? Let's see. Manage Nugget packages. Okay, so... Ray GUI, or let's just actually see the installed one. Is there like some sort of options or something? I don't really have that much experience into this one, and apparently there isn't, or at least it doesn't seem like. So let's check out Ray GUI pretty much and see if there is a Ray GUI there or not by any chance. And apparently not, so that's not really a big problem. This is probably just a header only library, which means we don't need to link anything. We just have to copy a header file basically. So like the implementation is not separate from the header, so we don't need to compile it like a separate library and link it. We just have to grab the header file. Okay, so we basically just have to install this guy right here, download it, save, and we could just add it to our project. Alright, so how we're gonna do this? Open folder in File Explorer, and let's add this here. And yeah, that's pretty much it. Now, let's actually add this as a header file here, add existing item, and we're gonna select my array.gui.h header file. And there you go. And now I could actually say array.gui. But since this is a header only library, we have to include the implementation. We have to say, as you can see here in the example, well, hold on, go back. Array.gui implementation. All right. So I'm just gonna copy this guy right here. And you basically have to define that macro in one single C file. So you can include the implementation inline in that C file so it can get compiled, right? You shouldn't do it twice, basically, in multiple files. Only in one file. Because the the header file is fine, or the declaration should be fine to be done twice, but the actual implementation should only be done once. Otherwise, it's ambiguous and it wouldn't compile. But anyways, let's define that. And yeah, right now we could use array.gui, though I honestly haven't used it for a very long time now. Let's see what's up. So just say if GUI button rectangle, then you give it the rectangle. Alrighty, that's pretty cool. Show message box. And this is all the controls we could make. We can make sliders, we can make all sorts of things, which is cool. Is there like a list thing? Because I'm gonna need it here. Yeah, there is a list view here, which is interesting. But let's just start by making simple rectangles buttons right now, really. Let's start there, I guess. And let's see what we got. Alright, so how are we gonna do that? We're drawing the rectangle. There we go, here. Okay. So here we're actually drawing those color rectangles, those color buttons. So how are we gonna do this? So instead of this draw rectangle rect, and instead of is mouse button down left thing here and check collision rect and all this crap, right? In fact, let me just leave them so you can see what is the difference that we're gonna do here. So I'm just gonna comment all those. Instead of all that crap, I'm just gonna say if GUI button, here the rectangle bounds, and finally the text of the button. But here we don't have any text though, we have an actual color though. So, okay, that's interesting. How the heck we're gonna do this then? Good question. Good question. Is there some other kind of thing that we could use here? Like in, Or maybe is there like, oh, actually there is a whole color picker in fact. So instead of even having buttons, we could just have a whole color picker in fact. But I'm not sure how that can be used. That's sick, but that's a huge color picker. And the thing is, how can I just have a button with the color though? That's the real question right now. How can I have a button with a color? Hmm. GY color panel. I don't really see that. Do we have rectangle bounds there? Let's try this color picker. Maybe. No. Like, how the heck? Hold on. Let me see. Raylib, colored button. How do you do that? Let's see. I don't think it's possible, apparently, which is interesting. Okay, what about an image button? Oh yeah, I forgot about the actual examples. My bad. So, alright, let's see here. Is this using Ray GY? No, it's not. It's using the raw texture rec apparently. That's interesting, huh? Well, honestly, you know what, dude? I think I'm just gonna use that color picker thing and see how I can use that directly, in fact. So we're gonna basically remove this whole thing, honestly. And let's just use a color picker. GY color picker, rectangle bounds. Let's see. Let's see if I can generate something real quick. Because I just want to test this first of all. See how it's gonna look like. What the heck is going on here? Oh my god, you know what? This AI is not really helping that much anyway, so let's just remove it, honestly. That sucks for some reason. Anyways, I mean, I would have expected it to be better for C, but well. Let's just say here is, well, 8 pixels by 8 in the X and the Y. The width, let's say, I'm not sure exactly, would this be like a button or the whole dialog directly or what exactly, so I'm just gonna go with this for now. Text, I don't know what that's for, and the color, I don't know what that's for either. Maybe I could check out some documentation here. GUI control panel, control panel, bar alpha, bar hue. Interesting. But the text, I think, is not being used here apparently, which is very interesting. What about the color? It's used in the GUI color panel. You know what, let's just try this anyways. Let's say, I don't know, red? Would that work? Is incompatible with point. Well, it's a pointer. Is that like an array or something? Is that meant to be an array? Unfortunately, this one doesn't have a lot of good documentation apparently, but nah, it's not an array. I'm not sure why it's seeking an address. You know what? Let's just try this. Let's not talk a lot. Let's just say address here, and let's do this. kind of lost. Lost in what? This function or variable may be unsafe. Consider using sprintf instead. Oh. Oh my god, this Visual Studio crap is very annoying. Let me just define that macro so it doesn't do this stupid warnings anymore. CRT secure, no warnings. Oh my god. Okay, hopefully that would work. So like this function use. So alright, let's try this. Hopefully it wouldn't bother me anymore with that stuff. What the heck? In result external symbol text to float referenced in function. In result external symbol, what the heck? That doesn't make any sense. Text to float referenced in function. Relib text to float. That doesn't include. Ah, I see. So I'm probably using the latest version, which doesn't match, of course. Yeah, probably. So let me make sure I'm using 5.0 here, I guess. But there's no 5.0 here. What the heck? Huh. I'm confused right now. Well, let's just try then 4.0, I guess. Well, I guess let's just try it. Source code.zip. Save. Let's try that instead. Show in folder. Extract all. Extract. Let's go. And then we got the source, read.gui.h. Alright, let's try that instead. So where is that thing here? Open folder. Let's remove read.gui.h from here. And let's grab this here. Let's go. Now this may get fixed. And yes, it did. Perfect. And yeah, we actually do have like a color picker here apparently, but it's too small. Alright, so I guess here's the deal. Here's the deal. Now I know. So we're gonna make a small button here, GY button, the bounce. So I'm actually gonna use, let's say this or whichever right here, and then the text would be color, I guess. So if that's got clicked, then returns true when clicked. Okay. Returns true when clicked. So let me just try this. I don't think this is how I'm supposed to do it. I should probably like hold a boolean and basically toggle it. Yeah, probably. Yep, exactly. That's what I need to do right now. So essentially is color, well, boolean is color picker or like shown, I guess. It's color picker shown. And now here what I'm gonna do every time it gets clicked, I'm gonna say is color picker shown. Well, G is color picker shown. is equal to not. So I'm basically gonna toggle it. So if it's true, it's gonna become false. If it's false, it's gonna become true. So yeah, and I don't need actually that. Now after that, we're gonna say if G is color picker shown, then we're gonna draw that GY color picker, and we're gonna draw it quite big actually. So I'm not sure, like 8. Let's try 50 by, well, and in the X actually just keep it as 8 probably. The width, let's say 100 maybe. Height 100. Let's see how that goes. And there you go. So right now I could actually toggle this. Now I got this color picker thing. But of course currently I'm not actually using the color output. I think it should be way bigger than that though, like maybe 200. And also let me change the canvas size, by the way. So the canvas size, it would be X. Let's leave a margin of 8 pixels. When it comes to UI, always leave some margin, otherwise it will look so ugly. And they need to be consistent. So 8 by 8. Well, what the Y was though? 50, okay. Leave it like that in the X8. And here the screen width minus the margin, the left margin, which is 8 pixels, and then minus the right margin, which is 16 pixels. Right? So, and here same thing, minus 16. And that should gives us, oh, actually, no, hold on. Only the screen width. The screen height though, no. So we have the minus 8 for the bottom margin, and then minus 50 of the offset of the top margin basically. So minus 58 essentially. And there we go. So we got this. Perfect job, right? Very cool. So now I click this, and now I need to figure out how can I actually like use that color. So let's see how we could do that. Oh, yeah, I gotcha. Gotcha, I see. It's a pointer because it needs to mutate it. That's why it's a pointer. I see. Alright. Okay. So then we're basically gonna say brush color here. Well, G brush color. G brush color. There we go. Right, so white. Now I could actually, choose another color. There we go. There we go. Now I could choose whichever color we want, and it works perfectly fine. The only problem though, I think, is, there we go, it doesn't really respect, but actually quite cool. Look at that. We got gradients already because of a bug. Well, it's not really a bug, it's just that we haven't implemented that thing yet. Is that when we're actually using the color picker, we should not be drawing into the canvas. Though how I'm gonna be doing that, I don't know. Well, actually it's quite easy though. If the color picker is shown, then we're not supposed to do that, I think. Is there like another kind of solution to this in like Raylib? Or should I just do it manually maybe? Maybe I should just do it manually. Is there like a Rage UI cheat sheet here? Rage UI cheat sheet. Maybe it doesn't exist. Okay, well, I just have to use the header then. Why not? Alright, let's see. GUI button. And what I wanted. Well, this kind of sucks. Because like I have to see the whole source code to actually see all the functions, I guess. Or probably not though. These are just the implementation. I could probably check out the. But meh. I don't know. For now though, you know what? Let's just do it manually, really. Fine. So, okay, how are we gonna do this? Let's see. So here basically we should make sure that we don't have the UI on, right? So if G is color picker shown, so if not is color picker shown, then we're gonna try to like draw the splines if there is a mouse button left. Otherwise I could just say I could actually merge both of these into one, like if mouse is left down and then not color picker shown, then we're gonna do that. So right now when the color picker is shown, I can't draw stuff basically until the color picker is off, and then I can draw stuff, and that would basically fix that problem, you see. So yeah, that's basically it. That's pretty sick. Now, one other thing though that I'd like to be able to do is to actually be able to resize the window. Right now we can't really resize the window, unfortunately. Of course, we gotta implement that too. But honestly, at this point, I'm probably gonna need another coffee. You know what? This GUI stuff is quite boring for now. I think I'm gonna try to start like implementing, you know, the brush smoothing using shaders. I think that would probably be way more interesting. And I haven't used shaders either in Raylib for a long time. So let's check out the examples real quick here. And let's see. I don't think it's that complicated, honestly. Let's see. Basic lighting. Now I want something very simple. I don't know, whichever. Actually, we can make use of a camera for the zooming and stuff, maybe. I'm not sure. Maybe. Yeah, I should probably look that up later on. But anyways, so you basically say load shader, then you give it the path to the shader, GLSL shader apparently. And then you get the shader location stuff, create the lines. Interesting. Actually, this would be a little bit crazy. Let's see. In fact, let's go to the repo here and let's go to the tags 5 because that's the version we're using right now. And let's go to examples. Where are the shaders here? Shaders. And yeah, they are in resources here basically. Shaders and latest ones. And there we go. So these are all the shaders over here. I just want something very simple, dude. I want, of course, a fragment shader. I guess let's just try it. It's gonna be a little bit hard, but hopefully we can do that. Let's see. Shaders, basic lighting. Alright, let's see. So the first thing that we need here, as you can see, is we're gonna need to load a shader, essentially. So let's go ahead and do that. So let's go down to our main function here, and let's just load a shader. So shader is equal to load shader. Now we could either get it from memory as a string, or we could load it from a file name. And the shader apparently in Raylib includes both the vertex and the fragment shader. So I'll just say, what they called it here, lighting.vs, lighting.fs. So I'm gonna call this brush.vs, comma brush.fs, right? Because these these shaders would basically generate the brush. So like instead of having just like drawing a circle, I want to generate the brush in the shader, so I could smooth it out and do other operations on it essentially. So this is our brush shader. Now of course we have to write some shaders right now, and shaders are basically like GPU code, like code that is ran inside the GPU instead of the CPU. So okay, how can I create a new file here? I guess maybe resource files, add new item, and let's call this brush.vs and brush.fs. There we go. So now let's just copy one of those shaders real quick. So I'm gonna go to probably examples, I would guess, and shaders, resources, and shaders here, GLSL, and base FS. This is like the base vertex thing, or what? Let me see some other example that doesn't have 3D stuff, so I don't need 3D here. Oh, actually define 0 nulls for vertex shader force usage of internal default. Okay, perfect. So at least for now I don't really need the vertex shader then. So I could just set it to null basically. So remove. Let's go back here, and we don't actually need the vertex shader for now. So because I just set it to null here. And for the fragment shader, what we're gonna do here is julia set.fs text format. Okay, so where is that julia fs thing? Julia. So I use Control F of course there, but yeah. So okay, so the first thing that I'm gonna need is the version here. Second thing is the file color. And of course I need the main function I'm not sure why there's like a VSync problem or some crap here. It's strange. Anyways. This really sucks. I don't know what's wrong with the UI here. Visual Studio. Anyways, so final color is equal to vec4. Man, why it's alternating color? That's very strange. Anyways, I guess let me open it with another thing. Brush, let me remove this brush FS and this brush F. Let's just open with the code, VS Code or Notepad. For me, I already have VS Code, so I could use that. And there we go. Alright, let's actually just try this and find out. Oh, hold on a second. No, I can't really do this though. I just remembered I'm not using circles anymore. Damn. Yeah, I'm using that. I'm using that Catmull-Rom spline. Oh my god. Well, I can't do this then. Yeah, I can't. I thought we were still using that circle stuff. Yeah, I can't. I wonder if there's some way to actually smooth that out. But basically my idea was that if we were using that draw circle, we would instead generate a texture for the brush. You know, in the GPU, using a shader. And then we would use that to draw instead of a circle, right? Well, I guess for now, we're not gonna do that. Let's just remove that stuff, honestly. Okay, let's remove this too. Delete. There you go. What we want to do next now is, like, is there a way to actually smooth the spline though? Hold on. How to smooth Raylib spline. Is there a way to actually do that? Or let me actually check the cheat sheet here. Hold on, where is it? The Raylib cheat sheet. Yeah, let's check out the spline stuff here. Oh, I can actually, I do have functions to just evaluate the thing. Yeah, that's interesting. That's interesting. Though, hold on. Why the heck this one actually only takes in 4 points instead of multiple ones like the other one? Well, that's interesting. But yeah. Well, honestly, I'm quite tired already at this point. So I think we're going to continue later on. Is there anything that we could implement real quick right now? GY, zooming. Not really, I think. Let me see. Yeah, we could have, like, let's say a save button too. But yeah, honestly for now, I'm quite tired at this point. So I think that's it for now. Oh my god, my pen doesn't work that well with this application. And yeah. So yeah, I guess that was it for the stream. Quite tired already. It was 2 hours. So yeah, that was it guys for this stream. Thank you all for coming. Thanks for Loop Luminary and Robert. And see ya everyone.